All right, so we are talking about vectors in 3D now. And vectors in 3D behave a lot like vectors in 2D do. So there's not a whole lot of new stuff to learn. We're just kind of moving towards 3 dimensions instead of 2 dimensions. So in 3D, like when we plotted points in 2D, we just had X and Y. And so if you remember way back from geometry, you have X, Y, and Z. And so that makes things a little trickier. And this one kind of like comes at you. And when you plot a point, so my example of a point was -4, 3, 2. So you would move 4 backwards on the X, then there's 4 backwards, 3 to the right, 1, 2, 3, and then up 2. And so with this, you kind of would make a box, honestly, with the height of 2 on all of these. So here's my little box here, height of 2 and distance of 4 on those. So you come up with this box where this back point here is the point where you went backwards 4 over 3 and up 2. So my point P would be right there. So you did all that in geometry, but just as a reminder, so how are they the same and how are they different? In 2D, we have things like X, Y, and in 3D, you guessed it, X, Y, Z. So one thing that we did was find the ordered pair, meaning find how far apart these points are from each other. An ordered pair is that thing X, Y that represents the vector. So when it was in 2D, if I gave you 3 points and B would be 4, 7, you could graph these on a graph like -3 up 2, +4 down 7. And then you could count, how far up and how far over to find the ordered pair that would represent this piece. Instead, I am going to give you, 3 points. It's supposed to be a 5, 0. Point B, 3, 1, 8. And point C, 5, 6. I just need 2 points. But each of my points has 3 components. I guess I should have said it like that, right? So you just need points A and B. And then my squiggly line left me. Guess I got too close to it with the eraser. And then to find the distance between these, you subtract. Remember the formula was like y2 minus y1 and x2 minus x1, and then z2 minus z1 gives you your x, y, and z. So to find the vector AB, I would take the b's and minus the a's. So I get 5, 6, 8, and I should pointy bracket these. So when you're doing this, it's just like in 2D where you would take 2 minus 4, that's a distance of, 4 minus 2, it's a distance of 2, and -7 minus 3 is a distance of -10, and you would know how long your vector is. So it's the same thing. The other thing that's the same is finding magnitude. Okay, so when we find magnitude, when we were in 2D, if I gave you a vector that was, let's say it's 7, 5 is my vector, and asked you to find the magnitude, you would square both of them, add them together, and square root them. So the square root of 49 plus 25, square root of 74. Okay, it's exactly the same in 3D. So if I give you a vector, let's just use our vector 5, 6, 8 again. This time you just need to square all 3 of them and then square root it. So then you get 25 plus 36 plus 64 equals the square root of 125. Okay, so that's the distance of that one. And then the last thing is just doing scalars, or, vector addition and subtraction. So if I gave you the vector v to be 1, 7, 1, and vector u is 4, 2, and 6, and asked you to find 4v plus u, same as we did in 2 dimensions, you would take v multiplied by 4. So I'd get 4, 28, 4, and add to it u, which is minus 4, minus 2, minus 6. And I would get 0, 26, negative 2, exactly the same way that we did vector operations before.